we have in today an Atari Lynx. This was, I would say personally for me, less popular than the Game Gear, but very similar in capabilities. This is a customer who has attempted to install a Benven screen and the console's died. Now this could be the screen installed by the customer. It could also be the screen itself. I do know that the Benvens can kill the power circuit fairly easily. The Lynx power circuit isn't the best in the world, and it's something I want to really improve with a clean power mod. But for now, let's just see if we can get this working for the customer, and he's also paid for one of our clean screens as the screen upgrade. This is the customer's console, so it's come already apart, which is fine, it saves us time. And they've included a bag of bits. The Lynx had two versions. This was the first, like a long version, and this is the second version. So you can see slightly smaller, and it depends which design you prefer. Personally, I prefer the Lynx 2 design. Now, the quirk with the Lynx that's different than most other consoles is it has a common positive. So the VCC rail, the red rail, is common across the whole board, including, I'm pretty sure, on some models, half of the what you'd presume would be ground pads are actually VCC pads. And it regulates by pulsing the ground side, not the VC side. So the circuit's basically backwards to most other consoles. It's also poorly regulated. So this is just a fairly basic circuit that toggles on and off and controls this MOSFET. It can fail fairly easy, especially under load, and then it can kill the main chips here. Due to this rather odd boot up system, I've made a safe boot guide on retro6.wiki that tells us how to safely power this up before just injecting 9 volts straight to here and potentially doing more damage. That involves gripping 5 volts onto the positive lead of the battery and taking the negative end with a game inserted. We'll probe on here, which is the common system ground. You can hear the speaker beep, and hopefully, if everything's okay, we'll get some game audio. If not, we've got some bigger problems. And luckily, there's the game audio. So that means at least the main system and the main ASICs, which would be basically a no-fix if these were dead, it would cost more to replace, are all working. Next up, and this is where it normally fails, we now need to test the regulation circuit works. For this, we'll change our bench to 6 volts instead of 5. We can now grip the 6 volts on the battery input, which would usually be 9 volts. We can then short pin 7, which is this bottom leg here, to pin 13 here to turn on without having the power button pressed. And that should show then hopefully a jump in current. So I'll just probe on the test pad by the number U6 and touch on there. We heard the speaker, and you can see we have 134 milliamps. I presume then we'll hear the game again, which we do. But now importantly, we need to measure the voltage as 5 volts. Remembering again, this is a common positive, not common negative. So we'll put our multimeter on the positive, set it to voltage, and now the important thing is we need to probe the system ground, which is this pad here, not the battery spring ground. You can see on that we have 5 volts. So that's good, the system is still fully working. Increasing to 7 volts now on the input, and we still measure the 5 volts. So now we're safe to power this however we like. We can put 9 volts on the input and power up as normal. In this case, I reckon it's fully working and it was just the Benven install that was wrong. I'll go and clean up these caps and shorten the pins, and then we'll install the clean screen. And that's all the capacitors redone. That took about an hour. The customer had basically cut off the old ones and left the pins in, so we've had to remove everyone, clear the holes, pull the pins, shorten them, and then obviously fit them back in order, as well as clean the whole board. We need to do this so we can actually warranty our work and trust that it's going to last, and some of those capacitors were just not good enough. Next up is the clean screen. If we take a look at these pins, it does also look like possibly some of them are torn or damaged from the previous repair attempt. So let's just use some hot air and flux to clean all this up first and reflow all the pins. And you can see now we're using some new Amtex flux. This is the stuff we used to use before, but the problem is trying to source genuine Amtex flux is really difficult because it's probably the world's most cloned flux. We can see a missing pad there, and a burnt one there, but overall so far doesn't actually look too bad. And with a good clean and realignment, you can actually see all the pins are there. I've just left this one to show you. This isn't a torn pad. This is where the customer thinks just pulled the old screen off. So this is the pad off the LCD, not this board. If we just reflow that with solder. And there we go, you can see when it's gone. The pin is in fact fine. Literally the only broken trace we have is this one. Every other one I've managed to keep in place and all be secured. So let's take a look at this pin here. On retro6.wiki, it is the clock A2 pin, so one of the 3 clock pins, so we do need it. But we got the via here. So when we're wiring to that, we'll just expose this via and tack onto this pad. That's all the wiring for the clean screen now done. I've done strain relief on the back, and then the harness just comes out. So we can now install this in the actual console shell and wire up all these wires. And with it all wired in, let's just now build this up and make sure it works. It's everything built back up. We've got Batman in and the charger. Let's just make sure this works. And there we go. So I'll give this a full test, make sure all the buttons work, and then we can get this one back to the customer.